hopper design. Hoppers are used in industry for protection and storage of powdered material. There are many different shapes of hopper and bin are routinely used, but in each case the design in turn is the same. So this is an example of the hopper design. The upper part is bin and the lower part is hopper, and the whole body are known as silo. There are three types of flow of solid in hopper, which are mass flow, funnel flow, and expanded flow. The differences between mass and funnel flow are shown below. The common technique that we use to measure the powder flow properties is the nickel shear cell test. The powder that we test is cellulose. Table 1.0 shows powder flow properties and Table 1.1 shows the data of flow function. Next, Table 1.2 shows the data of straight line equation. Then plot the graph of unconfined yield stress versus consolidating stress. Then the value of sigma critical are get from the graph, and the value of the theta and FF are determined from the data booklet. Next, the calculations are shown as follows. You can refer to the calculation to determine the volume of cylinder, mass of cellulose, and mass flow rate of the cellulose.
What is pneumatic transport? Pneumatic transport is a process which is a bulk material of any type are transferred by using a gas flow as the medium from one or more destination. There are two types of pneumatic transport, which is dense phase is the slug of material is forced by the pulse of air from one location to another. The dilute phase is the process of pushing or pulling air suspended material from one location to another by maintaining a sufficient airstream velocity with its characteristic as shown. Calculation in pneumatic transport have to know the gas velocity and pressure drop in pipeline. The step is as follows. Gas velocity. From the selection of pipe diameter 0.163 meter and the material is stainless steel pipe based on American standard sizing. The diameter of pipe must be larger than the diameter of hopper due to have suitable connection and to avoid spill out occur. To find result, alpha and beta is calculated, then we'll get unit equal to 32.290 meter per second. Next is calculation for pressure drop. Equation of pressure drop is as shown, which is contains 6 terms. Term 1 is pressure drop due to gas acceleration. Term 2 is pressure drop due to particle acceleration. Term 3 is pressure drop due to gas to wall friction. Term 4 is pressure drop related to solid to wall friction. Term 5 is related to the static head of the solid. Lastly is due to the static head of the gas. This is the symbol meaning in delta P equation. In horizontal section, term 1 and term 2 is required due to the assumption. In vertical, no assumption in term 1 and term 2. Term 3 is used by assuming it independent of the presence of solid. In vertical, term 3 is also used in equation of pressure drop. Hinkel correlation is used for term 4 in horizontal section, while in vertical, modified Cono and Saito correlation is used. For term 5 and 6 become 0 as the theta equal to 0 in horizontal, while in vertical theta equal to 90 degrees, thus term 5 and 6 is used. To calculate delta P horizontal section, we need to find all the unknown. From the Hinkel correlation, UPH is fine. Thus, from the Hinkel correlation, we can get the value of pH. Mass flux can be calculated based on the value of the mass flow rate and cross-sectional area. From the continuity equation, voidage value is 0.992. The UFH value is 32.55 meter per second. To find friction vector, Reynolds number is calculated. The estimation for CD based on that range is 4.193. For Hinkel equation, FT equal to 0.103. To find friction vector, again calculate Reynolds number, then use Baselius correlation to get value of Fg. Length of horizontal pipe is 7 meter. When all the unknown value is known, delta P horizontal can be calculated. In vertical, delta P need to find voidage for vertical. So CD/RET² is calculated and get value terminal Reynolds number equal to 0.27 from the graph. Then the terminal velocity can be determined. From simultaneous equation between these two equations, we get voidage equal to 0.993. In vertical, pressure drop is 0.63 kPa with length of 2 meter. Next, we use two 90-degree bands. Pressure loss per meter of vertical pipe is calculated as follows. Then the tapi band will get 0.95 kPa. Therefore, total pressure drop in the pipe length is 0.95 bar. This is our design for pneumatic transport with the length as stated in diagram. We use blower to push our powder along the pipe and rotary valve to feed the particle to the pipe smoothly. Figure below is show the movement of particle. As a conclusion, our design is dilute phase transport. Due to the superficial gas velocity is more than U salt, which is 32.29 meter per second. Our pressure drop is 0.95 bar. Our pressure drop is in range of the blower pressure that be used in industrial, which is 0.5 to 1 bar. We have a blower due to make our particle move to the end of the pipeline. And we have a rotary valve is used due to enable the particle to be fed at the control into the attachment pipe smoothly.
Let's proceed with the fluidization. What is fluidization? It is a unit operation that includes direct contact between a bed formed of fine solid and upward flow of a fluid. It's happened when the drag force equal to apparent weight of particle. The particle will lifted by the fluids and the separation of particle increase, then the particle will fluidize in the bed. The advantages of the fluidized bed is high mobility, good temperature control, and very flexible, while for disadvantages is costly, not all particles will fluidize, and difficult distributor design. Type of fluidize are bubbling fluidization, non-bubbling fluidization, turbulent fluidization, fast fluidization, and also particulate fluidization. Geldert has classified powder into 4 groups, which are Group A, B, C, and also D. It is based on the fluidization properties at the ambient condition, and it has been widely used in all fields of powder technologies. This is the classifications of the group. Group A has smaller particle and cohesivity becomes significant. Group B has poor fluidization qualities. Group C very cohesive particles and do not fluidize, while Group D has very large particle. What is entrainment? Entrainment is defined as ejection of particle from the surface of bubbling bed and their removal from the vessel. Entrainment happens when the terminal velocity is greater than superficial velocity. This is the illustrations of entrainment. Observe the red particle. This is the data required before we start the calculation. UMF value will be calculated by using Bayes and Geldert equations. Next, CD/RET² value will be calculated. Based on the graph, the Reynolds number will be get. Then, we can calculate the terminal velocities. So, based on the journal, we can assume the value of the U0. TDH value are required in order to assume the height of the fluidized bed. Voidage are required in order to determine the pressure drop of the fluidized bed. Based on the data distributions, the average diameter of particle will be calculated, and by using Zen's and Way equations, illustration rate constant will be determined. The last step is the rate of entrainment will be calculated, so we can get the value of the Q. From the calculations, the value of Vt is greater than U0. The height will be 8 meters. The pressure drop will be 7.192 kilopascal. The rate of entrainment will be 2.9724, and also the value of Q will be 4.5276 kg per second. This particle is able to be fluidized and entrained based on their characteristics, so our design is being acceptable. Thank you for watching. Bye.